set go? Wonderful good afternoon, you all out there. It's been almost 25 hours since we last talked to you, at least I last talked to you. I hope you're all doing fine, everything went well, and you had a 24-hour workload that you managed brilliantly. I would now love to hand over to Martin, who's the CEO of the Science Park Graz and also ESA Big Austria, and he gives you some important information towards the rest of the day, and I'll be back with some additional information afterwards.
Thank you so much, Katja.
Thank you.
Well, the most important information is actually a compliment, because I'd like to thank all of the great participants for the last 24, 25 hours of hard work, of dedication and compassion for the topic of climate change and connected with Earth observation. Most importantly, actually, I would like to thank our critical funding partners who are enabling ESA Big Austria as well as Science Park to perform undertakings such as this hackathon, which is first and foremost the Federal Ministry for Climate Protection, Environment, Energy, Mobility, Innovation and Technology. I needed to read it because it recently changed and I'm still struggling with the English terms. Internally, it's called BMK, which is much easier. But the point is, this ministry is performing incredible tasks and is really making a serious difference in all the sectors which I've just mentioned. And in this relation, I'm very, very happy and proud actually to present Margaret Miszkulnik, who's responsible for space and outer space affairs within the ministry, as our head of the jury today. It's a pleasure, Margaret, to have you with us. I appreciate the time you are making available for us. The same thanks go also to the FFG, to the Research Promotional Agency, in this case, which is also critically important for the operation of ESA Big Austria. And FFG is and ALR is represented by Elizabeth Klaffenberg, whom I most warmly welcome and thank for her time as well. I'm not gonna, there's also Christian Fuchs to be mentioned within Margaret Miszkulnik's team, who's doing a great job and supporting us on a daily basis. I'm not gonna get much longer, but I'm thanking you for being with us. I'm looking forward to a certainly stunning jury session, and I'm handing back over to the much more competent moderator, Katja. Thank you so much for being here.
Thank you, Martin. So back to you guys. We're almost there. I know it might be kind of exciting for you to get into the presentation. Just to give you a small idea how the afternoon looks like, we have 9 motivated teams, and each team has like 5 minutes of presentation, followed by a 2-minute question-answer session, and then the next team jumps in, and that goes on. And we plan on, so everybody who has to leave in between, please be back at 3:30 at this Zoom link again, so we can inform you and announce the winners of today's jury session. Well, please allow me to announce the team number 1 who's present. It's called Vinify.
Can you see me?
We do hear you, yeah, thank you.
Do you see the presentation?
I do actually see the presentation. Yes, please go ahead. Oh, you're now jumping through it.
Thank you. Okay, good afternoon, everyone. I'm here today to introduce Vinify to you, our solution to bring winemaking to perfection. I would like to start by introducing you to viticulture. Viticulture is the cultivation and harvesting of grapes. In the process of it, grapes must be carefully monitored throughout the season to determine when nutrients, pesticides, and additional water should be applied to optimize growth. Winemakers rely on several tools to monitor crop health and fruit ripening, including handheld reflectance spectrometers, grape and other analyzers. This means that viticulture is very labor and cost intensive and requires high levels of expertise. Now, what do we offer to solve this problem? We use remotely sensed intelligence by Earth observation satellites to complement or even replace traditional ground-based methods of managing vineyards. This in turn leads to minimized environmental impacts and risk, as well as an increase in efficiency, grape quality, and yield. The first question you might ask is whether that is even possible using Earth observation data. And the answer is yes. There have been a multitude of studies showing a direct correlation between remotely sensed climate and other data, and vine health, as well as quality and potential quantity of grapes. Now, what kind of data do we need? We started by gathering moisture index, temperature, and NDVI. Now let's see what this data can tell us. The moisture index shows us how well irrigated the plants are and whether irrigation is needed, and indicates plant health. The land surface temperature has a direct influence on sweetness and ripeness of the grapes and can tell us when the best time to harvest is. And the NDVI is a direct indicator of how healthy a plant is and shows us if a plant might need fertilizer or if it might require special attention. All those data points can help with management of the yard during the season. And since we have a wealth of historical data as well, we can also predict the expected quality as well as quantity for the upcoming harvest. Our business operates on a B2B concept. We provide a service directly to viticulturists that is monetized per hectare and year. And we also work together with insurance companies on a case-by-case basis, as we can provide valuable data about value of a property. A direct partnership with an insurance company that offers discounts based on using our service is also possible. We plan to start a business locally and scale up to a global level. Now, how does the market look like? The wine industry itself will reach an estimated global value of 284 billion euros by the year 2025. Precision viticulture makes up about 1.6 billion euros of revenue in Europe. It is a fast-growing market, and we expect to be able to reach a market share of about 10% as there are no direct competitors in our field at the moment. And here's our team. As you can see, we have a wide spectrum of expertise, such as business management, computer science, and graphics design. Unfortunately, our remote sensing expert dropped out at the last minute, so we would like to take this moment to express our gratitude to the Sentinel Hub team mentors that helped us a great deal during this hackathon. That concludes our presentation. Thank you very much for your attention, and if you have any questions, please feel free to ask them now.
So now it's up for the jury to post any questions. It's either online via the Zoom chat or by raising your hand in the Zoom, so we can actually put you online.
Well, basically, since there is no questions, I will abstain from raising my hand, but I would be interested in where you are planning to locate your operation, and what's the, like, you've given us an idea of the growth plan, but what the next steps, the next the next 6 and the next 12 months would be looking like.
So initially we would start very locally in Graz or somewhere in Austria. And since you need a lot of expertise in viticulture, we would work closely with viticulturists to further develop our product. And once we have a working product, we would try to expand more.
Okay, thank you.
So Well, I got two more questions arising here. I will read them out loud. Oh, three questions already. What would be your differentiation in relationships in relation to similar projects?
Sorry, can you repeat that?
What would be your differentiation in relation to similar projects?
Okay. So at the moment, there are no similar projects that we know of that focus on winemaking. There are projects that focus on general crop health. And our differentiation would be that because you need a lot of knowledge in the wine production, that we would specialize in this field and therefore differentiate to general crop health.
All right, thank you. Next question that came up was, what exactly do you plan to sell? Is it only to the insurance companies or is it to the winemakers too?
No, we would work directly with winemakers, and so they would be able to decrease labor costs, decrease manual labor time, increase yield, increase quality, and it would be paid on a yearly basis based on the size of the field. And insurance companies would come in maybe on a case-by-case basis, where if something happens, we have the data to give an accurate display of how much value that property had.
Great, thank you. And there are two more questions, which would be, how would you technical implement your solution? Would it be via a platform, or is it any other service, or is it an app that is on a laptop, cell phone?
We would probably make an app that makes it very simple for the farmers, as we want to take out complexity of the whole process.
All right, one last question. How would you integrate historical Earth observation data, and what would you learn from historical Earth observation data?
So historical data is very important for us, as we combine this with the data of the farmers, with historical grape yields and grape quality, and that helps us predict quality and quantity in the future as well.
All right, thank you so much. Time is over right now. Good luck, and thank you, Team Vinify.
Thank you.
I would now like to invite the team WB Pro S.
Hello.
Hello.
Can you see our screen?
We do see your screen and we do hear you properly, yes?
Okay, thank you. Our product is a VB-Wars, Waldbrand Vorhersagesystem, which is a deep learning-based European forest fire prediction system built on Earth observation and remote sense data. Maybe it's not a surprise here, the original name comes from German language. We are proud of having nice forests in Europe, and we know the change of climate endangers this beautiness of our home. To protect this, our vision is to reduce the damage of forest fires which have environmental background. Most of us in Europe think forest fires are problems far away from us, but this is not the truth. Almost 60,000 forest fires occurred in Europe only in 2018. This means one forest fire is a problem of about 6,000 people, just like a small town. If we are speaking about the concerned area, forest fires in 2018 affected more than 350,000 hectares. It means more than 27 times area of Graz. The availability of Earth observation and remote sensing data is really challenging. However, the data is basically free and publicly available. A lot of services request authentication, and API services have very limited features. As deep learning developers, we feel a contrast with other problems since EO and RS data requires deep digging into the field to access. However, anybody can find quite well the data sources, but it consumes an enormous amount of energy and time. Since there are no pre-processed datasets, developers could not compare their own models to other developers' products. The first question of every business model is what is the product? VB Force is a deep learning-based European forest fire prediction system. However, it seems the only solution is the fire prediction. We provide different services to different market participants or economic agents. Services can be grouped by time frame of prediction, which can be short-term or long-term. Short-term means one-day forecast. Longer term means an X-day forecast, where the limit is based on the quality of source data and the expected reliability of prediction. Other way to group services is based on the use model. We make a global model, but it can localize by local metrics or local sensor data. This helps to create better forecasts, but it should make a new model with a new train. Third part of models is a private model. We support private models where the server services run locally. This is a good solution for economic agents who do not want to share the locally collected data. This is a typical use case in the defense or intelligence sector. We can support transfer learning or other secure learning techniques to help to train the models faster and safer on a private server. We made a combined deep learning model to ensure high accuracy and flexibility at the same time. Accuracy comes from diverse deep learning layers, which can learn various connections in the data. Furthermore, we combine time series and non-time series data too. Flexibility comes from the idea of having three separated parts of the model according to the nature of inputs. We can handle image data, sensor data, and additional data apart. I mentioned earlier, it's quite difficult to understand EO data. This is the reason why we made a system with easy to understand outputs, such as probability of fire. To not lose important results, we add confidence scores too. It can be useful for optimization and service based on our service. We made a full business model canvas to show our product has the capability of living. Our team has 2 members at the moment. Yesterday, we heard there is a lack of developers in the EU industry. Our potential startup would match with the industry very well, since we need all experts aside from deep learning and IT at all. Our team and ID need first and foremost a chance to prove. During the hackathon, we just get in touch with EO data, and we are sure about the ability of creating really good prediction in the field of forest fire prediction in Europe, or later on the field, or maybe even globally. We are really proud of that. Within 2 days, we made a business ID, a lot of codes, and a short book about our concept. Unfortunately, the time was limited, and we couldn't typing faster. This was the presentation of VB Pros. We hope we have the chance to make our ID in an existing corporation. Please ask us anything. Thank you very much.
Thank you for your presentation, and thank you for just cutting in the right moment. I was just about to ask to keep the time. The first question is already here. Who should be the users of your product?
I don't know if you can hear me or not, because I will answer. Hello?
Yeah, hi.
You hear me? Okay, I'm Axel, the other team member. Our customers will be, we have 6 different market sectors. One of them is those who protect the forests, just like local governments or similar entities. The second market sector is who are working with disasters, for example, firefighters. They maybe will use the short, both of them can use the short-term prediction to make just-in-time decisions, and the longer-term predictions to make longer predictions, for example, to have some time to prepare or bringing tools from one place to another. And the other 3 parts can be local industry, which maybe uses longer time predictions to ensure, for example, the warehouse or something like that, or agricultural companies maybe. And it also can be, the fourth sector can be insurance companies who can sell our service further to the customers, to the end customers. For example, if we make a fire risk prediction, they can warn their customers to secure the homes or something like that. And the fifth part is defense or any other companies who maybe need this private model. And the sixth sector is anyone and everything else.
Great. We'll just get towards the next question that asks for which kind of data do you intend on using for your product and for your services?
Now we made some experiments with Earth observing data about Sentinel satellites, but the model has three main parts. One of them is image data, which can be loaded from satellite data sets and databases. And we can use any other sensoring data which can come from different sources. And the third part is now kind of static data, which is to the location where the prediction is. For example, what is the height about sea level, what is the distance from sea, and so on. There are a lot of possible data points which we can use. The concrete use of data really depends on what kind of opportunities we can make, like business opportunities or so on.
Great, thank you. There would have been a third question, but the time is over right now. Maybe the question can be answered in the chat directly afterwards.
Sure, we will.
Thank you so much, guys. See you at 3:30 latest for the awarding ceremony. I would now like to invite team number 3, Ekoten, or however you pronounce it.
Yeah, it's Ekoten.
Okay, great, thank you. Hi.
You can hear me?
We do hear you, and we see you out of space.
Yeah, I'm speaking from the International Space Station. Okay, I'm going to share my screen. Okay, can you see my screen?
We do see your screen, yes.
Okay, so hello everyone. Thank you for having us here. So our team, we wanted to answer the problem that cities are facing with respect to trees and the health of their trees, and we basically use satellite images for that. So the main problem is that we have why trees are very important. Let's just start with that. Trees are very important for cities for various reasons. They reduce air pollution, they reduce heat through evapotranspiration, and they are also great for creating good urban landscapes. So, and studies have shown that the average tree lifespan is in cities is around 13 years, in contrast to around 100 years in a natural environment. We need to improve the lifespan of trees in order to have a better urban environment, and for that we need to do this because to plant trees every 13 years is not good for the economy to start with, and it's also not good for the environment in general as well. A lot more resources are taken from the ground, etc. So we plan to do that. We plan to solve this problem by using a lot of data from satellites, as well as using some machine learning, and also combining them with in situ data. So here's our basic solution. So first, we have a structure. So we use indicators such as the vegetation index, the water index, the temperatures from the satellites, as satellite brightness temperatures, and we also use the population data as well. And these act as a qualifier condition for cities to basically answer some questions that are like, okay, does a place have enough vegetation already in that area? And does a particular location in the city, have enough water in that area or enough nutrients in that area? And is the place heavily populated as well? Because then it contributes to heat. Does the place have right temperature? So these are going to act, these indicators, which are very well measurable, will act as some kind of a qualifier. So it's a true or false. And then after that, we also take into account the atmospheric composition, which we can get from the Sentinel P5. So because we know that certain chemicals in the atmosphere have a significant impact on the health of a tree. NO2, we know that NO2 and CO2, have positive impact on the growth, whereas CH4, SO2, and O3 have negative growth. So we can take that into account, and we take the probability of this, of the occurrence of this chemical in a whole year, and create a little index, a quantifiable index to present this atmospheric composition into it. And when we take the qualifiers and the atmospheric composition and process the data using our algorithms to calculate what we call the potential plant growth index, which would be an index between 0 to 10, 10 being that in that location, if it's 10, that is the best location for a plant growth. A user who would use this can see all this data that includes the qualifiers and the probability, and finally the PPGI. And also, we will be able to see in 2 different locations in the city, so as to compare what is the PPGI for these 2, or maybe more locations as well. And that's the general idea. I'm going to pass over to my other teammate who will explain the business model. I hope that she can get us. Okay.
Can you hear me?
Yeah, go for it.
Okay. So yeah, we plan to make this platform available through a SaaS model. So the platform will be accessible by our user through compensation of a yearly subscription. Our target client will be any actor in the urban environment. So it can be private sector or public sector. So we can work directly with municipalities or with urbanists, landscape architects, anyone that needs to identify where the best location is for the tree growth, to optimize the tree growth, and then expand the lifespan of our city trees. For now, we have identified quite a wide market. Over the world, there is more than 4,000 cities that have 10,000 plus inhabitants. So this is quite a wide market, and we are confident that since climate change challenges are increasing, the problem of increasing the tree density in cities will be more and more present. So this is a problematic of today. And then regarding our team, we are today 3 people. We have very complementary backgrounds. Shagnik has the urban environmental background, so this is really helpful to take into account different aspects of the problematic. Tanya is the GIS specialist, so she will take care of all the technical challenges. And I am the business developer, so I can take care of the marketing and business side. We will necessarily need more members as the project grows, but this is our foundation for the moment. Thank you very much. We're looking forward to listen to your questions.
Thank you for the presentation. Now we are waiting. The first question is already here. Maxime, how do you plan to deal with the typical pixel size of the imagery, medium resolution, tens tens of meters that you have shown in your presentation. Will this resolution be sufficient to capture small-scale changes within the city?
Can you hear me?
We do hear you.
So we actually, what I showed was, as I said, they were just images, but we're not trying to use them more geographically. We're trying to like detect how the occurrence of those chemicals in a particular time period, say for example a year, and then we're planning to do some statistics to see how much they occur over a time period. Because we saw throughout the time we saw that there are certain times when these chemicals are present, and there are certain times that they're not. So we're planning to use that, because otherwise it's rather difficult to downscale those large pixels. For the indicators, they're available at 10 by 10 from Sentinel-2. So we have worked with that before, and we can work with that in general as well. I think they're fine for us. But yeah, the pollution is a bit of a challenge. So we're using statistics for that. We're using them for statistical and probability analysis on this. Yeah. I hope I answered the question.
Thank you. Just waiting if there's another question arising from the jury members. No, I think all questions are asked already. Thank you so much. See you at 3:30 again.
Thank you.
I now welcome
very much.
team. Thank you. Bye. I now welcome team number 4, Dream Green.
Can you see my screen? Hello. Can you see my screen?
Yes, we do see your screen, and we do hear you.
Okay, thank you. Hello, everyone. My name is Mihir. Second challenge mentioned by the previous team, and yeah. So what was the motivation to take up this challenge? So this is a small post which I made on social media 2 years ago. And here you can see, so on the top, it's a place called Maninagar, from the place from where I come, from India. And on the bottom, it's the city of Munich, where I used to live. And you can see a very stark difference in the green area of both the cities. And yeah, I was just sharing my feelings. And when I saw the same challenge given by the GeoWill team, I quickly took it because I have personally experienced that problem. As you know, we have set very high targets under Sustainable Development Goals. And one of the target, 11.7, it says provide access to safe and inclusive green and public spaces. WHO has this recommendation that everyone living in a city should have a green space of at least 0.5 to 1 hectare within 300 meters of their house. So I looked at the city of Graz. So this is the Graz city, and in the green color, you can see all the green area, green spaces that we have in the city. So I used the OpenStreetMap data that was available for the green spaces. Here, all the green spaces are marked in the polygons. But there were some issues in this data. So for example, you can see there are a lot of mini polygons within the polygons. So I had to do a little bit of corrections. And then I finally get a green space map of the city. When we overlap it with the buildings within the Graz city, we can find out, okay, which buildings do not have green space within 300 meters of their house. So we can find out which houses do not have green spaces. And I found out that 7% of the building area of the Graz city do not have this green space. Now rest of the people, they have green space, but it's also important to look at what is the quality of that green space. And for that, I use the NDVI indicator, which tells us the greenness of a particular green space. So the more the darker the shade of the green, more is the greenness. So there is the more tree density. So it's a bigger tree and not small grass. So this is the NDVI image of all the green space. And if we combine both the data, then we can find out, okay, which green space is of higher quality and which one is of lower quality. So the light green shade is of lower quality and the dark green shade is of higher quality. To give this quality some number, I created one quality index, and right now I have only included 2 parameters, but later on I plan to add more parameters. So right now I have added 2 parameters. First is green score. So the more the greenness, higher is the green score. So if the NDVI value is higher, then I give higher points to that space. And if the NDVI value is lower, I give a lower score to that green space. And similarly, area score. Research says that the bigger green space is more valuable for people and also for the biodiversity, because it can support more number of biodiversity species. So if the green space is very big, then I give them higher score. And if the green space is not very big, if it's small, then I give them lower score. And then I add up the score, and based on that, I give them a quality index. So here you can see the distribution of the quality of green space in Graz city. And we should be happy that 80% of the green space in Graz is of quality 9. And 15% is quality 8, and so on. So it's a quite good situation, but yeah, there's still some scope of improvement. But if we look at the buildings which has access to this quality, then we find out only 72% has access to 9 quality green space, and 14% has access to 8 quality, and so on. So, so insights like this can help city administrators to improve their green spaces. Just to conclude, what will be the way forward? So I also want to add more population parameters. So I also want to look at how these green spaces are distributed with demographics and population density. So whether rich and poor have equal accessibility or not. So something like that. I also want to add more quality parameters like tree species and tree age. So right now in the quality index, I have only included 2 parameters, but I want to add more parameters. So maybe a green space which is having rare tree species should be more valuable to us. And if the green space has older trees, then it should be more valuable. And my final aim is to create an open source and easy to use solution for everyone. So it should be usable for all the city administrators, garden departments, multilateral agencies who want to monitor the progress of the cities, researchers who want to do research, and most important, citizens, so that they know how their city is performing. So that's my goal. So in the end, I would just like to say we must remember what Tolstoy said, that the first condition of happiness is that the link between man and nature should not break. And that should be the goal of all the cities. And that's what we work for. Thank you so much.
Thank you too. Now we need to watch the time a little bit. We got 3 questions that came up. You see them in the chat, which says already 4. Wait, now I need to scroll back up. Just real quick, how do you handle the fact that you also had the Graz airport as a green space, but it's restricted area, so you can't really access that? Would be one question. And the other one is, how could you make money out of this product you're presenting here?
Right. First question, restricted. It's a good question. Actually, I was trying to incorporate that because right now I have used the buffer method, where you just take the linear distance that, okay, I'm living here, and within 300 meters, what are the green spaces? So I have only considered that. But next step, in the more advanced step, I would like to do a network analysis in which you actually use the road network and you find out, okay, where actually I can go, and then what is the accessibility. So, but for that, you need higher computational resources, and it's not possible on the local computers, but on the bigger computers. So yeah, that would be the next step. And about the revenue.
Sorry to interrupt you. I just need to take care of the time right now. Would you be kind enough to go into the chat room of the Zoom link? There are a couple of questions there, and there's also a question on the YouTube channel. So you might want to just answer the questions right away, either in private chat or answering to all of us.
Yes, definitely.
Thank you so much for this presentation. And I would now jump over to team number 5, Space Enigma. Okay, team 5 isn't available right now. Then we jump over team number 6, Zombie Fire, please. Team number 6, Zombie Fire, please. Can you just wave your hands or make yourself visible for us so we can let you in? Okay, one more last call. Team number 6, Zombie Fire.
Hello. Sorry.
There we are. Great.
Let me just share the screen with you guys. Okay.
Thank you.
Okay, can you see the screen now?
We do see your screen and we do hear you. Yes.
Okay, yeah, perfect. Okay, so hello, welcome to you all. So today we are going to be talking about zombie fire. It's not unlike most fires, but it can lead to the most traditional fires. So my team contains 4 members. And we are a bunch of technical, science nerds, basically. So let's move forward. So in this presentation, we'll be talking about the background of our topic, that is zombie fire, the problem at hand which we are trying to solve or approach, and how our solution looks like, sort of an outlook. And then we'll proceed to final product, the business proposal, and then your time of questioning us. So on the picture now you see, it's not a scene from Grand Theft Auto, but these are the wildfires in recent times that we know, California and Australia in the same year, I think. In this picture, you see not fire, a pleasant scenery, but believe me, there is a fire. And once after a certain time, it will look like this. So how we reach from there to here. So zombie fires are the fires from the previous fire ready to start once again. it's like they never went away, but they were just hidden in the plain sight. We usually see these fires more prevalent in Europe, in Arctic region. I mean, fortunately, Europe does not, see fires like the US or the Australia or the most recent Amazon. But these zombie fires are nearly impossible to extinguish because they work underground. They stay inside. So they can act like a ticking fire bombs below the snow-covered, beautiful Arctics. And from the starting of this year until now, they have produced almost 244 megatons of CO2 in last 8 months. And we all know about the Siberia high heat waves where the temperature reached around 38 degrees. This was very alarming. On the map on the right, you can actually see this is the temperature between January to April. And if you see carefully at the top right, you'll see a lot of very dense red cloud. This is not a cloud. This is an indication of a fire. Yes. So problem at hand, which we are trying to solve, is basically predicting the zombie fires, efficient evaluation of satellite data, which is once again, I think, a pretty good metric to detect or let's say predict it. So what we think is there has to be some preconditions, which are very hard to study, by the way, and of course they are geography dependent because not every region is plain. There, I mean, in Europe we have a lot of mountains, plain, grass, snow-covered land. And another problem which we'll be having is an end-to-end solution for the interested parties so that they can control their input and output behavior, but they will get the prediction of a fire. And obviously the solutions hold like billions of dollars and preservation of our precious ecosystem as well. Now I will let my colleague take the charge for a minute.
Yes, so what we did here was yesterday starting to think about the problem and how can we approach this quickly. So we went out through this default 6-step scientific approach to come up with a solution, how to kind of communicate the problem to our stakeholders. So from the preposition is, can we detect those zombie fires? We set up a few hypotheses in the next slide, and then finally bring a solution to our clients or to the user of the data through an open system. So next slide, please. So the hypothesis is, when we look at those zombie fires, can we from a low and mid-resolution satellite imaging find the new features for the next fire season? And then we are looking at reanalysis data, land cover, topography for a high level profile at 1 kilometer by 1 kilometer pixel size, because that's the MODIS data. Next slide. So that's on the high resolution. So we're working from the MODIS fire product as the envelope on which the fire stopped in this fire season. And then we try to kind of bring out a profile with the high resolution satellite data to predict if that same pixel will fire up next year under certain conditions. So if you go to the next slide, then we see an area in America, or in Canada, actually. This is Canada. This is the Chuck Creek, and here we see in April a fire occurring. Throughout May, then the fire workers start to work on that fire, and they get it under control. And during the late season, it disappears. Kind of, there are still spots, but the fire in winter disappears and is underground. And then you see it slowly firing up again in May. And that's the fire analysis. So we go through this detailed Sentinel product pipeline to find out the right indicators in this research to see the fire, go through the season, and then in the next season predict which cell would fire up again.
Can you please just keep the time We
We
got
are
a couple
almost
of
done.
seconds. Okay,
Yeah.
go, please
Yeah,
ahead.
yeah. So let me take you through the approach that we took. We actually structured the data that could actually help our main call. So we gathered the data through Sentinel API. We wrote a script and got the data. And the first line of business what we did was, let's see if our intuition and all the literature study that we did, if it's correct or not. After that, we actually formalized a metric for prediction so that we can determine the precondition and if we can see if there can be a pattern or not. And fortunately, yes, we did see a pattern. And for the future work, actually, we will be training a machine learning model and improve automation through devices like IoT as well, which can supplement the data from the satellite. And our solution outlook is that we actually look at the previous fire incident timelines, for example, May to September last year, and then
Sorry, we really need to cut right now.
Yeah, so
We're really running out of time right now.
Middleware service provider from where we can get the satellite data, get it and give it to end user. And with time, our proposal is to sell it to the governments and organizations like UN or the local authorities, and we'll keep on improving this thing. And I think now we have pretty much confidence in our metric system, and now we can move to full-fledged machine learning thing, which we tried, but it's another story. Yes, thank you so much.
All right, thank you. Since we're out of time right now, for any question answers, please use the chat right now. And I would now get back to team number 5, Space Enigma. Are you there? If so, wave your hand, do something that we can find you. All right. Any success? No, not so far. Okay, team number 7, UbiCube.
Hello?
Hi.
Can you hear me?
We do hear you. You're team number 7, UbiCube, or team number 5?
No, team number 7, UbiCube.
Oh yeah, okay. Team number 7, UbiCube.
All right, I'm gonna share my screen.
Please go ahead.
So, can you see my screen now?
Yes, we do see your screen.
Okay, sweet. So I'll just go ahead and start. All right, so hi everybody. My name is Andreas. I'm one of the future co-founders of UbiCube. Life is full of difficult decisions, and for a lot of those decisions, geographic features are an important factor or a driving factor. For instance, when you're looking for a new apartment, of course, geographical location plays an important role. Or if, let's say, a retail chain wants to open a new store, of course, geographic location plays a role. Or from a more environmental perspective, for city developers, it's sometimes hard to decide where to expand a city to in a healthy and sustainable way. And the key to smart decisions in this context is information. But the problem is, in our case, this geo information is rather of low quality most of the time, like in terms of temporal and spatial resolution. The information is rather scarce with respect to geographical coverage, and the information tends to be kind of expensive. And that's exactly what we try to solve with UbiCube. So with UbiCube, we basically deal with spatial patterns. We analyze them. We try to understand what are the driving factors of spatial patterns. What are the reasons how they evolved like they did? Then, of course, we try to model those geospatial patterns and eventually transfer them to other geographic areas and predict also future evolutions of geospatial patterns. From a more technical perspectives, we're using satellite data and points of interest data and all kinds of other geospatial data sets in a machine learning framework in order to derive the desired information. At the moment, we are focusing on socioeconomic, socio-demographic, and socio-environmental attributes and their spatial distributions over cities. But let me give you some examples. For instance, the net household income, the spatial distribution over London in the UK, or another example, the population density in Buenos Aires in Argentina, where you can see, of course, distinct spatial patterns, and there are reasons behind those patterns. And this is what we try to find out and to analyze. Another example would be a socio-environmental attribute. In this case, you see a map of how happy the people of Vienna are with air quality in their area. And air quality, this is also the topic that we chose for the Copernicus Hackathon this time. So in our framework, for the hackathon, we included information from the Sentinels and also this other additional data sets we got, in addition to the air monitoring stations and the data we got provided. We used those air monitoring stations as training data, at least part of it, 80% for training. And we basically had a look at the locations of the stations and tried to find out what are the driving factors for the differences in the NO2 estimates or NO2 measurements from the stations. So what are the reasons that there are such differences among the city? And our framework and this deep learning revealed that the most important factor is the proximity to streets, and also to a lower degree the vegetation, if an area is vegetated or not. And this is also consistent with our literature review we did with other literature. So the goal was, okay, to get all this information and try to find out the driving factors and use this information to derive high resolution NO2 estimates. And let me give you some examples of our results. So we are looking at the city of Graz, of course, and this is what the NO2 measurement from the satellites looks like in the original resolution and the 1000 times 700 meters. This is the monthly average for July. And with our downscaling, the results look like that. So you can see urban patterns a lot better, differences in the urban areas, and of course, it's really obvious that the streets are the most prominent source for NO2. And we downscaled it in this case to a 10 by 10 meter spatial resolution. What's really interesting, the validation, we also used, of course, the validation data to validate, and the correlations with the station data, they improved from 0.2 to 0.8 in the Pearson correlation, which means a roughly 400% improvement, which is kind of impressive, I would say. So anyways, we see this as a proof of concept that our approach could work. Of course, we need some more fine-tuning and some other possibilities to investigate, but we're positive. What we want to do with this information, to include this in our data cubes as a possible parameter for other areas and for questions we want to answer with our clients. So our business model. We are using all kinds of data sets we are deriving in different ways. First in consulting projects where we develop solutions with our customers. Kind of simultaneously, we are offering our data sets as an on-demand spatial insights online. And the goal and the vision is to have a platform, an artificial intelligence platform, where you can bring your own data, use our data cubes, use our machine learning models in order to derive spatial patterns and eventually have a good information to take a decision. We are situated in the location analytics market.
Yes, do you hear me?
Yeah,
Just
I'm almost done.
Yep, thank you.
Okay, in the global analytics market, which is a growing market, of course, and we plan to have our share from this market. From the team, we are kind of diverse from geo, IT, Earth observation, machine learning, and our advisor, Thomas Blaschke. Probably a lot of people of you know him. And yeah, we've been working on this whole thing in a couple of months. And at the moment, we are looking for funding and venture capital. And we already have some interested clients, and now it's time to accelerate this whole thing, and I think that's why we are a perfect match for the ESA Accelerator program. Thank you.
Thank you, Andreas and team. Are there any questions? Yes. Would you build your own data cube infrastructure or deploy in some of the existing ESA data cubes and platforms?
Well, we plan, or we are using the Open Data Cube repository or the library, and build our own data cubes, because it's a kind of specific. For now, we're doing this for urban areas, and so we plan for having data cubes for different cities. So yeah.
Right, thank you. Maybe you would just want to keep on checking the Zoom chat if there's any other question coming up to your presentation so far. It was just this one question. Thank you.
Thank you.
Now I would like to invite team number 8. Herbie Wishes.
Yeah.
Team number 8.
Hi there. I'm already here.
Hi.
I'm Jeet. I'll be presenting my screen now. Yeah. Is it visible?
Yes, it is.
Okay. So, hi everyone. First of all, I would like to thank the organizing team for giving us this platform to provide our solution. I'm Jeet. I'm representing Team Herbivicus, and we provided a solution for use case 1, that is urban areas in GeoVal challenge. So the thing about urban places is like the urban population is almost 55% in 2018. And by 2050, it is expected to increase to 68%. The problem with urban areas is that it depends on factories, power stations, and a lot of cars. So which results in a lot of emission. And 65% of total global emission is from from the urban areas. These emissions has a lot of harmful effects. They cause permanent damage to human bodies, and these emissions like NO2 and SO2, these are invisible and they cause long-term damage. Like in 2016, there were more than 4.2 million premature deaths. Not only that, these emissions come down to Earth in the form of acid rain, and they cause huge biodiversity loss. For example, from 1995 till 2017, it has been found that overall 50% of the Great Barrier Reef has been lost due to the pH and temperature change of the sea. Not only that, these emissions also are the huge cause of global warming and climate change. This year, we have seen that Arctic has recorded 38 degrees Celsius, and we have also seen huge Arctic fires. So, ladies and gentlemen, we provide our solution, Air Forte. So what we will be basically doing is we'll be using Sentinel data, satellite data from Sentinel 5P, which provides us with the air quality of a particular, it has global coverage, and it gives us information about the air quality. But for cities, the resolution of this satellite is huge, like it's 7 kilometer by 7 kilometers. So we will be also needing the data from in situ sensors. Through API calls, so we will be getting this sensor data into our database. And using this data, our plan is to make machine learning models, which will give prediction like long-term and short-term. Short-term like 1 day, and long-time like 7 days or like 3 days, something like this. And this data will be available to anyone through API calls, and we can use this data to visualize in our application and also externally. So I'll give you a small demo of our application that we developed. So basically, this is our platform. It's already working, and as you can see, this is the sensor data of grass, and you can see this is the pollution data. And in addition to this, we will be also providing the predictions in this platform. So basically, how is this solution useful? First of all, for municipalities, it can be huge advantages for emission concentration mapping, and for urban planning. For example, if I want to construct something, or if I want to build a factory, then is it okay to build in a city or something like this? It can also be very useful for the citizens. It can help increase awareness among the people, and in our platform we can also provide some health programs and health suggestions. Through our platform, we also plan to provide API for third-party applications, and how can these APIs be used? For example, you can develop navigation-based apps. If you want to travel from one part of the city to another part of the city, this navigation app can give you a route which has less pollution. So there are like a lot of opportunities for this kind of solution. So what will be our business model? First of all, our portal will have free and paid services. The basic service like a small short-term prediction will be free, and there will be some other free services. But for long-term predictions, this kind of services will be, of course, charged. In addition to that, we as a company will also be providing software solutions, and which will be tailor-made based on customer needs. Not only that, we will also be providing API subscriptions, which will be charged in pay-as-you-go format. So this is our team, Habivikas. Ankita Sen was the project architecture, and she's also the front-end developer. Priyanka Paul is currently studying masters in electrical engineering, and she's also a full-stack developer. Me, Jeet Biswas, I was involved in the image processing of the Sentinel-5P data, and also I was developing some models. So basically, this is our planet Earth. So come join us to make this place a better, sustainable future. Thank you.
Thank you for your presentation. Is there any question coming up from our jury? As I don't see any questions popping up right now, I would like to jump into the presentation of our last team, the team DFire.
Hello. Hello.
Hi.
Hello. Hello.
Hi, Leila. There we go.
Yeah. Can I start the screen sharing?
Please go ahead.
Yeah. Just a moment. Okay. Okay, everything okay?
All right, we see it.
Okay, hello. Let me start the timer so I know what's the time. Hello, my name is Nella. I'm from the DFire team, and I would like to introduce you to our concept. Our vision is to assess the risk of fire outbreak using machine learning and to improve the allocation of resources. So 8 out of 10 wildfires are caused by humans in Austria. And this is the map showing fire outbreaks from data collected from 2017 to 2020. If we take a look where this fire happened, where did they happen? We use the Korean land cover classes, so the product of Copernicus. And it showed that most of the fires happen at industrial or commercial habitats, but also significant amounts of the fire events happened on natural or semi-natural habitats, such as pastures, or natural grasslands, broadleaf forests, and so on. So we wanted to combine human and environmental factors to assess the risk of fire, especially in the context of climate change, which makes the ecosystems vulnerable to disasters. And as you know, the fires cause great risk for human lives and also property damage. So our solution was to take the innovative fire prediction model And to have, the goal was to have the better decision making and to have better resource allocation in the end. So how did we do that? We wanted to test our model. We took points from VIRS data, which contained fire events data. And we also created non-fire events so we can test the model. And then for the human impact input data, we used OSM data. This is the map showing railroads. And we also use the data from camps and alpine huts, because we assumed where there is increased human activity, such as hiking or more dense traffic, there is a higher risk of fire occurring. And then we also had the environmental input data. This is a map showing FAPAR data from EODC. Data above Graz from FAPAR, and which is also connected, FAPAR is connected to gross primary production. And we wanted to test this as well as the leaf area index and F-cover. We utilized different technologies so we can have a better scope of the problem. And then this data was processed using random forest, neural network, support vector machine, KNN, and logistic regression, which showed to be most suitable. And we got that 70% of the fire events were correctly identified as fires, and 80% of the non-fire events were correctly identified as non-fire events. So that was the accuracy of the model. And then we took this model to make fire risk maps, which enables us to define the area. This is example of area of Mariazell. And we calculated the fire risk. So this map shows where there is a higher and lower fire risk. And also on this map, you can see the fire stations. So the idea is to get the fire teams and the firefighters to specific locations where there is a higher chance of fire occurring. And also, if the fire happens, to show them the best suitable and accessible route to this fire outbreak. So our business model was to, we have two parts, which is business to customer B2C, which is subscription based, and and the other part is B2B, which includes SDK and API sales. We are focused on the government. And as we look at the market, our market is mostly, so our product can be used by whole European Union and many stakeholders. But for this particular model that we used, we chose Austria and mainly their government and forest departments. We are better than our competitors because we have a better accuracy and we reduce costs. And also we use EO data and anthropogenic features. So we use this combination. In the future, we would like to improve our models using Sentinel data for Sentinel 2, 3, 5P to get soil moisture, nitrogen, fuel index, wind speed, and so on. And if we're given a chance to get to the Copernicus Accelerator program in the 3 years' time to get to the market. Our team was composed of different people. Many of them are students from different countries and different backgrounds, which made a really diverse team with a lot of inputs and also a lot of fun. And we would like in the end to join us on our mission to fight the fire and save lives and money. Thank you.
Thank you, Team DeFire. I do see there's already the first question up in the chat, which is very convincing presentation. Is the Federal Chancellery your first customer, or is there anybody else also?
Okay. So is the Federal Chancellery your first customer? For the first phase, yes. This is the most, and then it can allocate the resources to the fire departments, and this is the first phase that we thought about.
All right. There are some congratulations coming up as well. And okay, there we go. So far, are there any other questions from our jury members? Maybe you just want to check the chat a little bit in a couple of minutes. Thank you, all of you right now. It was very interesting 1.5 hours of presentations from you guys. I think there were some excellent ideas brought up within the last couple of hours or days. You know, usually an event like this will be with like interaction and physical meetings, and you would all get some goodie bags, and instead of handing you over goodie bags or ship them to you, the organization team decided to do something special. So you might just want to check your email accounts, because there were some trees planted in Cameroon for you, and you can claim them for yourself. So you just want to check them and see the emails that just came in from Science Park Graz and Isa Big. And with those informations, I would like to have a little break for you guys. You just take another 25 minutes, and let's meet at 3:45 in this room again. We will now have the discussion with the jury members, and then the awards will be handed out to all of you. So please, we don't want to kick you out because that's not really the friendly way to do it. You just want to leave the meeting so it's easier for us to continue with the discussion. Except the jury members, please stay in. Jury members, don't leave. All right, so see you at 3:45 in here again. Bye. All right, hello everybody. Sorry it took us so long. There were some really intensive discussions right now going on because of all your great proposals that you sent us and prepared and presented to us. I don't want to, take any longer. I will start with handing over the word to Christian Brieser from EODC, who will announce the special prize from EODC. Yeah, this will be a special prize. And after that, it will be GeoWill, and they will also announce their winners. After that, I will announce the student prize, the second prize, and will be happy to hand over the final and first prize announcement to Ms. Mishkulnik as the head of jury, and she will let you know who's going to have the ticket for the Copernicus accelerator. And now I'm back for Christian Brieser for, oh no, GeoWill first.
Okay, thank you. This is Michael Riefler speaking from GeoWill, Head of Research and Innovation, and thanks to all participants who actually addressed the urban challenges we provided to you. So it was very, very nice solution presented. I just would like to highlight the three. So there was the team Herbie Vickius addressing air pollution in cities, and I would say that the idea they presented was in general was quite nice. What for me was a little bit missing is actually the solution. Say the data you presented was not that convincing, but overall nice. Then we had UbiCube, actually quite also nice overview of data cubes and how you can actually leverage the data from a data cube. And I must say, I like the results I've seen for the prediction of NO2 values distribution in Graz. And the third solution I would like to mention here is from Dream Green. So very solid analysis, nice overview. So you spend a good amount of your time for development. Here a little bit the missing thing for me was then in the end the pitch. So I think there's some potential for improvement. Thinking about business case, also how you can actually present, market yourself. And from this, I would like to provide the GeoWill special prize to Dream Green. In fact, since I really liked what you have presented in terms of analysis, and I think it would be worth to spend the GeoWill prize maybe in doing some professional training for marketing or business development. And therefore, yeah, I'm happy to announce this. Thank you. Congratulations.
Thank you so much.
And with this, I guess I'd like to hand back.
Moderator, please. Moderator. Katrin.
I'm sorry. Christian Brieser is muted right now, and we would like to have Christian Brieser announce the winner of the special prize of EODC.
Yes, thank you very much. And first of all, thanks to all presenters. It was have been really quite good talks. We already really looking forward now to hand over the first EODC prize. So after looking and rating all presentations that we had around the first EODC prize, I even was just in the room of my daughter collecting one symbol for that, as we are around remotely. That goes over to DFire. So DFire getting prize number 1 from EODC. And on very short notice, we have also decided to announce a second prize from EODC. So in the second prize, there I have a small medal around. The small medal with the second prize goes over towards UbiCube, as they also have quite a great pitch presented, and we think that we can hopefully support them in their activities and encourage them to continue their ideas and developing them further. So all the best from my side, and many thanks for your presentations. Thanks a lot.
Congratulations, both of you. I'm now really happy to announce the student prize, which is worth 1,000 euros cash that you can probably invest in some, business development courses, or just come and see Jeremiah and see what's best for you to do. I'm happy to announce the team of Zombie Fire with the student prize. I would love to shake your hands, but unfortunately it's just like a handshake over the screen right now. Congratulations.
Thank you so
and
much.
To get further,
Thank you.
Pardon? Okay, there was some interruption. Okay, thank you. And the second prize, which is also worth a 1,000 euro cash amount, will go to UbiCube. Thank you guys, congratulations. And now the most important part is ahead of us, and I will hand over to Ms. Mishkolnik. She was head of jury, and she will announce the winner of the overall hackathon and the ticket to the accelerator program. Thank you.
Yes, now we come to the final. And I'm proud to announce that the first prize with 2,000 euro and the ticket to the Copernicus accelerators goes to DFire. Congratulations and all the very best. And at the end, I would like to add, you were all great. Thanks a lot for participating. Super.
Thank you.
Thank you, all of you, for participating, for bringing in those interesting ideas and those great solutions. Also, thank you, jury members, for taking the time and getting through this long discussion this afternoon. Thank you to the mentors who took care of all of you during the last 24 hours, and the organizing team around Jeremiah and Isa Big, as well as Science Park Graz. And you don't even see them, but there are two really enthusiastic guys sitting next to us and doing all the technical support here. What shall I say next? Have a wonderful weekend, go and celebrate and enjoy this, really great hackathon. Thank you. Have a good one. Oh, by the way, if you need anything, if you have any questions, please get in touch with Jeremiah. He will set you up with the jury members, and he will, let you know how you get your money transferred to your accounts. Thank you, and bye. Have a good one.